As I told you, I'm going to make a series of important derivation for semester 2 exams. So out of them, today I'm going to tell you one. Position of maxima and minima in Young's double slit experiment. Before we discuss about this, what I'm going to discuss, you all know, I'm going to discuss about interference. What is interference? You all know when two light waves of same frequency, travel in a medium simultaneously, then due to their superposition, at some points intensity of light is maximum, while at some other points intensity of light is minimum. This phenomena is known as interference of light. What I told, that when two light waves of same frequency travel in a medium simultaneously, it means जब सेम फ्रीक्वेंसी वाली लाइट वेव किसी मीडियम में एक साथ ट्रेवल करती हैं और सुपरपोज होती हैं, then due to their superposition at some points intensity of light is maximum, while at some other points intensity of light is minimum. This phenomena is known as interference of light waves. I hope you all know this. How? You should understand the point where these waves are meeting in same phase, there you get maximum intensity. Where these waves are meeting in different phase, there you get opposite phase. These waves are meeting in opposite phase, there you get minimum intensity. So this is interference of light. So in interference of light, as I told, somewhere point intensity is maximum, at some point intensity is minimum. So for that I am going to write a derivation. You all know Young's double slit experiment. As you know, this is a very important question, that is interference is possible by two different sources of light. Then as you know, it is not, sustained interference is not possible. Sustained means in that type interference where maximum intensity points and minimum intensity point are separate. जहाँ maximum मिल रही है, their intensity is maximum. Where you are getting minimum, their intensity is minimum. Right? भाई जिन पॉइंट पे आपको मैक्सिमम इंटेंसिटी मिल रही थी वहाँ मैक्सिमम मिल रही, जहाँ मिनिमम मिल रही थी वहाँ, ये इट इज ओनली पॉसिबल व्हेन लाइट कम्स फ्रॉम सेम सोर्स, बिकॉज सोर्सेज शुड बी कोहेरेंट. फॉर सस्टेन्ड इंटरफेरेंस ऑफ लाइट, द लाइट सोर्सेज शुड बी कोहेरेंट. कोहेरेंट मीन द फेज डिफरेंस बिटवीन देम आइदर सेम, आइदर कांस्टेंट और जीरो, या तो उनके बीच फेज डिफरेंस जीरो या constant phase difference, right? So here I am going to discuss position of maxima and minima. See here, in Young's double slit experiment, we take a light source S, and light rays coming from light source S falling over two slits S1 and S2. What are slits? Arey bhai, we take a screen, one pinhole we make in that. Alpine से by alpine we make a pinhole, that is slit. बहुत महीन सा, right? So let you have a light source S. In front of that there is a screen. First screen you can say. In that have two slits S1 and S2. महीन से pointed छेद, right? Two slits S1 and S2. The light starts from light source S. When falls on two slits S1 and S2, then one light wave starts traveling from S1 and moves at point P, while other light wave starts from light source S2 and moves toward point P again. As one moves from S1, that is bypass S1P, other moves from S2, that is bypass S2P. Now what we do, we put a perpendicular from S1. ऑन S2P हमने S1 से परपेंडिकुलर S2P पे डाल दिया. Now this S2A is the path difference. Actually what is this? This is path difference between two waves. ये जब दो वेव्स एक दूसरे के साथ चलती हैं, राइट, तो एक इस पाथ से जा रही है, एक इस पाथ से जा रही है, देयर इज अ पाथ डिफरेंस S2A. देयर इज अ पाथ डिफरेंस S2A. Actually we have to find out this path difference S2A. For this we are going to do all exercise. Now we join this point C with point P and we get a triangle PCO. PCO. In triangle PCO, if you see, this angle is theta. Be taken. Similarly, if we put perpendicular from here, then this angle is also theta. Both angles are theta. Right? Because I like to tell you, these are similar triangles. These are similar triangles. Right? So, in right angle triangle, S1, S2A. S1, S2A. Sin theta equal to perpendicular upon hypotenuse. What is perpendicular? This is perpendicular. The side in front of theta is always perpendicular. So, sin theta equal to S2A. S2A. And hypotenuse. What is hypotenuse? S1, S2. Now again you take right angle triangle. In right angle triangle PCO. In right angle triangle PCO. What is tan theta equal to PO upon OC. What we assume? We assume distance of this screen from this screen is capital D, and distance between these slits is small d. Small, very very important derivation for this year second semester exam. S1, S2 is the distance between two slits, be taken as d, the small d, and distance between first screen to second screen, this is suppose that second screen. Again I want to repeat, you have a light source there, from that light falls on slits S1, S2. Now after that another screen here, when this light travels from S1 it moves and S2 it reaches at P. At P, these waves can meet in same phase or in opposite phase. If these waves will meet in same phase, we get bright point. If these waves will meet in opposite phase, we get dark point. Two types interference, as you all know, constructive and destructive. Interference is two types, constructive and destructive. In constructive interference, when waves meet in same phase, we get bright point. When wave meets in opposite phase, we get dark point. That is destructive. So what we are going to discuss, in triangle S1, S2A, we taken sin theta equal to perpendicular upon hypotenuse. Because S2A we have to find out. We are doing all rehearsal for this. This is part difference. And when we take triangle PCO, then tan theta equal to PO upon OC. As you know, theta is very small. Theta we taken very small. So when theta is very small, then sin theta approximately you can take tan theta. And both are equal in that condition. We can take sin theta equal to approximately tan theta. So S2A upon S1, S2 equal to PO upon OC. What is S2A? S2A, as I told, part difference. That you have to find out. What is S1, S2? That is D. that is distance D. What is PO? PO is distance X. What is OC? OC is capital D. So as to A equal to XD upon capital D. This is your part difference. What is X? X is the position of fringe. What are fringes? When interference takes place, we get dark and bright bands. These are known as fringes. This time, dark and bright bands of equal width. Right? These are known as fringes. Okay, that is another thing. So S to A equal to XD upon capital D. As you know, if at point P we get bright fringe, we get, there are two conditions. One is there are two conditions for constructive interference. These are also very important. Listen carefully. First, there are two conditions for constructive interference. Very important condition. Number one, for constructive interference, the phase difference between two waves, should be what? Phase difference between two waves should be 0 or even multiple of pi. 0 or even multiple of pi. The general formula for phase difference delta phi equal to what? 2m pi. 2m pi. What is m equal to? M equal to, you can take 0, 1, 2, 3, 4. This is value of m. This is value of m. 0, 1, 2, 3, 4. So, phase difference between two waves should be 0 or even multiple of pi. 0 or even multiple of pi. And path difference between two waves, that is delta x. Delta, that is m lambda. M, again m equal to 0, 1, 2, 3, 4. Again I want to repeat, phase difference for constructive interference 0, 2 pi, 4 pi, right? And path difference should be 0, lambda, 2 lambda, 3 lambda, so on. For constructive interference, the phase difference between two waves should be 0 or even multiple of pi. And path difference should be 0 or whole multiple of lambda. Now you see here, so path difference is m lambda. What is? M lambda. This is your path difference. Path difference is m lambda for constructive interference. So here in place of x I am writing xm d upon capital D. Again I am repeating, for constructive interference means bright fringe you are going to get here. Here at point P you are going to get bright fringe. For bright fringe the path difference should be m lambda. M lambda equal to xm upon d upon capital D. Now you cross multiply this. Xm d equal to dm lambda. So xm equal to dm lambda upon small d. Small. This is position of mth bright fringe. M. Now you want to find out another xm plus 1 fringe. Xm plus 1 fringe. Then in place of m you are going to write m plus 1 lambda upon small d. Lambda upon small d. Now you want to find out fringe breadth. Xm plus 1 minus xm minus d m plus 1 lambda small d minus dm lambda upon small d. Now d m lambda plus d lambda minus dm lambda upon d, because both have same denominator. Both have same denominator. I opened this bracket dm plus 1 lambda dm lambda plus d lambda minus dm lambda dm lambda dm lambda. So beta equal to d lambda upon distance between two bright fringes is known as fringe breadth. Distance between two bright fringes is known as fringe breadth. So we find it out fringe breadth for bright fringes. Suppose that if at point P instead of bright fringe we get dark fringe. So what is condition for dark fringes? I hope you all know two types of interference is there: constructive interference and destructive interference. Constructive interference, intensity of waves is maximum. That their condition I told. Now if we have to discuss destructive interference, for destructive interference, phase difference should be 2m minus 1 pi, and path difference should be 2m minus 1 lambda by 2, lambda by 2, right? 2m minus 1 lambda by, for destructive interference, the phase difference should be phase difference should be pi 3 pi. Put here m equal to 1. You are going to get pi. M equal to 2, 3 pi, 5 pi. For the destructive interference, the phase difference between two waves should be odd multiple of pi. Should be odd multiple of pi. And path difference, if you want to discuss delta x, that is lambda by 2, 3 lambda by 2, and 5 lambda by 2, so on. For destructive interference, the phase difference between two waves should be odd multiple of pi, and path difference should be odd multiple of lambda by 2. Odd multiple of. Now what you can do? X m again. So in place of S2, this is path difference. Now we are assuming that at point P dark fringes we are going to get. What we are going to get? Dark fringes. For dark fringes, 2m minus 1 lambda by 2 equal to xm d upon capital D. Capital xm d equal to 2m minus 1 lambda by 2 into capital D into, so xm equal to m minus 1 lambda d by 2d. Right? This can be written in other form also, that I can tell you lambda by 2 you can take inside. Lambda by 2 you can take inside. Right? Then it will become easier. Just a moment. If we take lambda by 2 inside, then xm d equal to lambda half we take inside, so m minus half lambda d you can also write. Half you taken inside. If you not understand, I like to show you 2m minus 1. Half you taken inside. Half will come inside. So 2m upon 2 minus half, 2 cancel, m minus half. M minus half. Right? So xm equal to m minus half lambda d upon small. Don't confuse this. Half you taken inside. When you take inside half, 2 by half means 1. 1 by half. So how? So this is your fringe breadth graph, dark fringe. Dark fringe. Okay, now I can remove this. For dark fringe, this is, if we take another fringe xm plus 1, that is m plus 1 minus half. Instead of m, you take m plus 1. Lambda d upon d. 1 minus half means half. 1 minus, एक में से आधा निकालने आधा बचा. So 1 plus half lambda d upon small d. This is xm plus 1. Now what is beta equal to? Xm plus 1 minus xm. So m plus half lambda d minus lambda d upon d. Subtract both of them. Subtract both of them. Again denominator is same. You can open it. M lambda d plus half lambda d minus m lambda d plus half lambda d upon d. M lambda d cancel. Half lambda d, so lambda d upon d. Beta equal to d lambda upon small d. In both conditions, fringe breadth remains same. This is fringe breadth of dark fringe. This is fringe breadth of bright fringe. So again, I want to repeat it that for destructive interference, the phase difference should be odd multiple of pi, and path difference should be odd multiple of lambda by 2. So here I explained about fringe breadth. After that, angular fringe breadth. What we can discuss? Angular fringe breadth. What is angular fringe breadth? I am going to remove this. Okay. Here. Angular fringe breadth. Okay. I am going to remove hole. For angular fringe breadth, I will come at my point. As I told you, position of xm equal to what? D m lambda upon small d we will proved. This is the position for bright fringe. Position for bright fringe. I proved xm equal to dm lambda upon small d. You can see in your video. Now you have to find out angular. So theta m. Angular position. This is position in distance. Now angular position of this fringe. Theta m. Theta m equal to xm upon d. Xm upon d. Why you written this? Theta equal to arc upon radius. Theta equal to, so you taken this arc, this is taken as radius. So theta m equal to xm upon d. When you divide, you will get d lambda upon small d. Further, you take another fringe, theta m plus 1, that is d. Theta m plus 1, what will you get? Theta, this is your theta m. If I say theta m plus 1, what are you going to get? I written something wrong, I think. dm lambda upon d. I don't. That's why I am not doing. xm equal to what? dm lambda upon d divided by d. What will you get? M lambda upon small d. M lambda upon small d. And now next fringe. This is position, angular position of m fringe. Now you want to find out angular position of m plus 1 fringe. That is what is m plus 1 lambda upon small d. This is position of m plus 1 fringe. Now you want to find out theta, angular fringe breadth. Angular, subtract both of them. M lambda plus lambda upon d. M lambda plus lambda. Theta equal to lambda upon small d. This is your angular fringe breadth. Again I want to repeat. This is position of fringe, bright fringe position. And what I am going to find out? Angular position of fringe. This angle. So angular position for this fringe, what we taken? Theta equal to arc upon radius. So xm upon d. By dividing d, you get m lambda upon d. This is for nth fringe. Next fringe is m plus 1. M plus 1. For that m plus 1 lambda upon d. So theta equal to, this is angular fringe breadth. As we find out, normally fringe breadth d lambda upon small d we find it out. That was the positional fringe breadth. कि कितनी उनके बीच की चौड़ाई थी, तो उनके बीच में एंगल का कितना डिफरेंस है, that we are going to find out here. Theta equal to theta m plus 1 minus theta m. When you subtract both of them, you will get lambda upon d. This is all about this derivation. I hope you all understand. Any problem regarding derivation or anything, please write your views. Then I will try to give you more better content, right? And I hope out of these 4 derivations, 5 derivations I given, at least you will get 2 in your board exam. Best of luck for exam, and I will try to make some other videos regarding board exam. Thank you.